have in total 5 sessions. We will start with an introduction to the Excelsior project. We will continue with a session for the Excelsior plans, and then we will have 3 sessions on future demands and opportunities. We will strictly follow the agenda. The sessions will be recorded and uploaded in YouTube. Please note that we will allow questions only through the Q&A, and the chairman will address your questions to the speakers in the end of each session. If we don't have enough time to answer all the questions, we will try to answer them via email later on. I would now like to invite Professor Diophantos Hatzimitsis, the coordinator of the Excelsior H2020 project, to welcome the workshop and give a brief introduction. He will also be the chairman of the first session.
Good morning. Dear Chief Scientist for Research and Innovation of the Republic of Cyprus, distinguished speakers, ladies and gentlemen, on behalf of the consortium of the Excelsior Horizon 2020 Team Phase 2 project, I would like to express a very warm welcome to all of the participants to the first virtual Excelsior International Workshop. This workshop is a part of the annual workshops that will be organized on a yearly basis with the participation of all national, Eastern Mediterranean, Middle East and North Africa, the MENA region, and international stakeholders, and addressing all the different activities of the new entity of the Radosenis Center of Excellence. For example, infrastructure, research, education, and innovation through entrepreneurship. The main aim of this workshop is to present the plans and prospects of Excelsior-related infrastructure for space operations, monitoring, and environmental research, and how this can be used for the project and challenges in the Eastern Mediterranean. We are more than proud, as a consortium, as an organizing committee, of having more than 300 registered participants from more than 41 countries for this workshop. Please consider our sincere thanks to all of the participants. Taking this opportunity, I would like to express my sincere thanks, gratitude, and appreciation to the President of the Republic of Cyprus, Mr. Nikos Anastasiadis, for the strong commitment and support of the Cyprus government to the Excelsior project. I would like to express my sincere thanks to the Chief Scientist for Research and Innovation, Dr. Nikolaos Mastroiannopoulos, and the Deputy Minister and the staff of the Ministry of Research and Innovation and Digital Policy for their support. To all the speakers for their kind acceptance to join us today, to the European Commission, the Government of the Republic of Cyprus, the Cyprus University of Technology for funding this project. My sincere thanks also goes to the CUT2, the Cyprus University of Technology, the strategic partners DLR, Tropos, NOAA, and Department of Electronic Communication from the Cyprus government, as well to the other 95 supporting and committed organizations to the Excelsior project. My sincere thanks to the members of the External Advisory Board and the members of the Board of Directors of the Radosenis Center of Excellence for their great support. Finally, I would like to express my thanks to RIA and our project officer, Antonio Vencio, for his strong support and dedication. I am 100% confident that you will enjoy our first Excelsior virtual workshop. A short introduction before we start. Cyprus University of Technology is one of the 3 state universities in the Republic of Cyprus, located in the center of Limassol in Cyprus. It was founded by law on December 2003 and welcomed its first students on September 2007. The university consists of 6 faculties, including the Faculty of Engineering and Technology, in which the Excelsior is hosted. The Faculty of Engineering and Technology consists of 3 departments: the Department of Civil Engineering and Geomatics, the Department of Electrical Engineering and Computer Engineering and Informatics, and finally the Department of Mechanical Engineering and Material Science and Engineering. In 2007, within the Department of Civil Engineering and Geomatics, a small lab, the Remote Sensing and Geoenvironment Lab, and then the upgraded center, the Radosenis Research Center, has been established with the main research pillars: Earth observation, remote sensing, and geoinformatics. In 2019, the proposal with the acronym Excelsior under the Horizon 2020 widespread team call has been granted. In October 2019, the Excelsior Horizon 2020 teaming project has been started. What is Excelsior? Excelsior teaming project is an acronym of the full title of the project name is Eratosthenis, Excellent Research Center for Earth Surveillance and Space Monitoring of the Environment. The project is built on the capacities of the existing research center at the Department of Civil Engineering and Geomatics of the Faculty of Engineering and Technology of the Cyprus University of Technology. What is Eratosthenis Center of Excellence? It's an autonomous center at the Cyprus University of Technology established through Excelsior. It aims to be viable, sustainable center of excellence in Earth observation, space technology, and geospatial analysis. The new center is a continuation of the existing Eratosthenis Research Center. What is the consortium? CUT, DLR, NOAA, Tropos, and DEC, plus 95 committed organizations. Why Excelsior? The answer is here. Space-based Earth observation, where 3 continents meet, facing common challenges for making citizens and societies resilient to sustainable development. In our capacity as a consortium, acting in the domains of Earth observation, geospatial information, and space applications, we are motivated from the fact that the European Commission will invest 16 billion euros in space, building upon Galileo and Copernicus. We see the opportunity in the fact that the Cyprus government is investing to become full European Space Agency member. We are inspired from the fact that Earth observation has been identified by ESA experts as one of the 3 domains for potential future plan for European corporate stage project in Cyprus. We are fully aligned with the smart specialization strategy for Cyprus. We are pushed by Cyprus University of Technology that has commitment to invest 8 million euros and the additional 15 million euros from the government. We feel the responsibility since our center is the only Earth observation center in Cyprus since 2007, and we are stimulated from our mission to upgrade the existing Eratosthenis Research Center. We are determined to implement the Excelsior Horizon 2020 project and the new autonomous center, the Eratosthenis Center of Excellence, through trust, transparency, and teamwork. The goal is to make the harbor city of Limassol and Cyprus a place where researchers from all over the world can interact and the base for a future innovation. Thank you very much for your attention. Now we can move with the next speaker. We are proud that we have Dr. Nikolaos Mastroiannopoulos, our Chief Scientist for Research and Innovation from the Republic of Cyprus.
Good morning to everyone, dear distinguished speakers, honorary guests. I hope you hear me well. Good morning to everyone and welcome to this great initiative. It is with great pleasure that I address you today at the first International Virtual Workshop of the Excelsior project with a view to tackle space operations and environmental monitoring in Cyprus. First of all, I would like to congratulate the organizers, the Eratosthenis Center of Excellence, not just for today's initiative, but also planning to hold this workshop on an annual basis. Establishing such initiatives as institutions is crucial, especially for our region, in the Eastern Mediterranean, Middle East, and North Africa, as they bring together distinguished scientists from across the globe to discuss the latest developments in topics that can address a wide range of challenges. Organizing such events like today's workshop with the participation of representatives of pioneer and world-class leading agencies from abroad, such as NASA and the German Airspace Center, as well as prestigious academic and research institutions. These can facilitate the exchange of knowledge and international best practices while providing access to top league expertise. This knowledge exchange chain is not only important for the development of the center itself, but it also contributes to unlocking the local research potential and to strengthening the role of Cyprus as a research and innovation hub. Furthermore, it's of utmost importance that Cyprus enhances its extraversion by developing targeted strategic collaborations in the fields including science, technology, and innovation. For us, as the national research and innovation governance system, but also for me personally, as the chief scientist and the chairman of the Research and Innovation Foundation. Creating strong synergies will transform Cyprus ecosystem to a fully developed, functional research and innovation ecosystem is a top priority also for myself. Ladies and gentlemen, we are particularly proud of the establishment of a world-class center of excellence in our country, which facilitates access to new scientific networks and unlock new opportunities for economic development. In fact, the Excelsior project is one of the most ambitious in the research and innovation history of Cyprus, aiming to establish our country in the field of space-based technologies. Space and related technologies were once considered to be too advantageous for our country as a small island, a possibility that not many will have dared to consider 20 years ago. And this is very important for the center itself. As we all know, Eratosthenes aspires to become a fully functional innovation hub in digital technologies and research excellence center in the MENA region, focusing on fields of research such as Earth observations, geospatial information, and space applications, while it's creating an ecosystem where state-of-the-art sensing equipment, cutting-edge research, targeted education services, and entrepreneurship come together. During this critical time when humanity is facing many challenges, such as climate change and natural disasters, we must take advantage of related technologies like Earth observation data analytic in order to tackle these challenges from a different angle. I strongly believe that with a comprehensive approach and connection with similar international infrastructures, we can ensure long-term Earth observations and establish useful services on both the national and European level. My friend Diofantos, as a molecular biologist, I can acknowledge the importance of a microscope, also the great importance of using a satellite imaging system to observe the Earth. It goes in a similar way and in a similar fashion, and the importance is fundamental. I would like to take the opportunity to express our full support towards the aspiration of the Center of Excellence to transform Cyprus into a national and regional hub for Earth surveillance and space-based monitoring on the environment. In addition to the total 15 million funding that the Republic of Cyprus will allocate to the Center of Excellence, we have committed to support Eratosthenes and together with other centers of excellence in overcoming barriers and achieving sustainability in the long term. More specifically, support is already provided by facilitating communication with public authorities, such as the Treasury and the Audit Office of the Republic, as well as liaising local and regional authorities to develop new digital tools and services. Additionally, the political decisions taken to reform the national governance system of research and innovation, as well as the recent establishment of the Deputy Ministry of Research and Innovation and Digital Policy, and the Research and Innovation Foundation continuous support reflects the commitment to adopt research and innovation as a fundamental pillar of the new model of growth, capable of expanding the productive base of Cyprus economy. Sincerely, I hope the investments using Earth surveillance, innovative technologies would continue being made in order to build the foundation of a modern and therefore sustainable development model which would provide solutions to real social challenges whilst having an economic and social impact. It's my, before I close and give the floor to the specialist, they say the key of success is being at the right place at the right time. But also very important is to be the right person in the right place at the right time. I am sure of success as the team from Eratosthenes is the right team at the right place in the right time. Thanks for your attentions. Once again for participating in today's workshop, and I wish the discussion would prove to be valuable and beneficial to everyone in future plans that we have. Thank you very much for your time.
I'd like to thank our chief scientist. Thank you very much. Let's move to the next speaker. Is brief overview of Excelsior project. Kyriakos Themistokleous, project manager at CUT Eratosthenis Center of Excellence.
Over the world that watching us. We have a lot of participants today. I would like to thank also the chief scientist for his support and confidence to us. And I would like to give a brief overview of the project. I'm Kyriakos Themistokleous, I'm the Excelsior project manager. And right now, as Diophantos explained before, the whole concept of the Excelsior project is to upgrade the existing remote sensing and information lab that we call Eratosthenis Research Center. We established this the last 11 years in the Cyprus University of Technology. And now we're trying to upgrade this to the Eratosthenis Center of Excellence, to a sustainable, viable, and autonomous center of excellence. What we are planning is to make the Eratosthenis Center of Excellence an excellence research center with the highest quality, and not only that, but compete through the national and European and international level. So we are really, as the chief scientist said, this really ambitious project, but also a really innovative project for Cyprus. The partners that we have is the universities, the Cyprus University of Technology, is the Department of Electronic Communications of the Deputy Ministry of Research, Innovation and Digital Policy, is the German Aerospace Center, DLR, in Germany, is the National Observatory of Athens through the Beyond Center of Excellence in Greece, and the Tropos Institute in Germany. So we are a good set of partners. We worked before and we had done a lot of research in the past 10 years. And now this is the opportunity to work together to make a center of excellence here in Cyprus. Here, the submission of the project, it was 2 years ago. Here you can see the team when we submitted the project. And here is our team during the kickoff meeting in November 2019. You see that our family is growing and is growing as we go because we're hiring a lot of personnel the next few years in order to support the center. The public inauguration was done in 22nd of November of 2019 by the President of the Republic of Cyprus, Mr. Nikon Anastasiadis, and it was a big event. It was done in the Cyprus University of Technology. Here you can see pictures from the event. We had an amphitheater full of people that came here in Cyprus to join us in this inauguration event. We have an external advisory board that is consisted of international members. We have Dr. Vincent Ambrosia from NASA, Dr. Marcello Manaresi from Italy, is an independent consultant, Professor Lena Halunova from the Czech Technical University from the Czech Republic, Peter Zell, Dr. Peter Zell from Austria, Dr. Simonetta from the European Space Agency, and Mr. Daniel Barok, which is from Israel. So we have an international advisory board that is advising us in any step that we're doing, and they give us directions how to proceed. Now, our partners, as I said before, we have partners from Germany, from Greece, and Cyprus. DLR will support us in planning and establishing the satellite receiving station. We have the National Observatory of Athens that will seek to establish the sustainable links between the Eratosthenis and Beyond Center, but help us develop the center in a lot of the areas. We have Tropos that is helping us establishing the ground-based remote sensing station. And of course, here, as I said before, the Department of Electronic Communications that will help us provide the links for the local and government community and promote the space issues on the national level. So it's a good set of partners that actually will help us set up the center, and not only that, give us directions of how we proceed with the project. Now, why teaming? We thought that a teaming project will help us lead to the excellence that we're looking for. Now, as I said before, we're in transition of 10 years of establishment of the center here in Cyprus, and now we are ready to go for the next 7 years of establishing this center, and not only that, but make it a regional center. And this could help the countries and regions that are lagging behind in terms of research and innovation performance to attain a competitive position in the global value chains. So it's not only that we establishing something that is going to be in Cyprus, but we want to establish a regional center. We want to compete in the European level, and not only that, but in the international level. So we are really looking forward to set up the center and start working in these research and innovation activities that we are setting up. Now, as Theophantos said before, Cyprus has a unique geostrategic position, and this position actually helps us to go on and do research in Earth observation. We have a good climate. We have 300 days of sunshine a year, providing excellent weather conditions here for cloud-free satellite images. And of course, we have a unique position to support the region. This is something that actually is, we are motivated in actually setting up the center and work with the neighbor countries, the European countries, and not only that, but reach the international era. Now, we have a lot of areas in this Center of Excellence, and as you know, Cyprus is an island, so we have a lot of opportunities to deal with research in land, in ocean, in atmosphere. So there's a lot of crossroads here that actually give us the opportunities to do the research that we want in Earth observation. Now, as I said before, we are establishing a super site for aerosol and cloud monitoring in the Eastern Mediterranean, Middle East, and North Africa, that we are in the center here. We are trying to see if we can deal with issues like droughts, water shortages in the EMENA region, deal with issues in the rehabilitation programs that we have in the Eastern Mediterranean, Middle East, and North Africa, disaster risk reduction, and regional and establishing a regional digital innovation hub for Earth observation in Cyprus. Now, as I said before, the Eratosthenes Center of Excellence has a potential to become a catalyst for facilitating and enable regional and European and international cooperation. But not only that, but with the availability of funding instruments for Earth observation, we can become a national and compete in the national and European level. Also, we have other issues that even the chief scientist mentioned before, like how to deal with the big data management and analytics, the development of the space strategy here in Cyprus, and other issues that we want to explore through the program. As I said before, this is a continuation, so we have a lot of background with research projects, and that's why we want to go with to evolve in a way through the Center of Excellence. We have a lot of networks and supported already. We have NASA, the European Space Agency, GEO, the Israel Space Agency, RAISE, Copernicus, Actris, ESO. You know, there's a lot of international networks that we already reached and we are part of. So we have more than 500 members from Europe and international level. So this gives us a more ability and more confidence that we can reach these partners and go on with Horizon 2020 project and take advantage of the availability of this funding from the Horizon 2020 and the government of Cyprus. Now, what we are planning to do, we're planning to hire about 112 personnel in the next 7 years, 132 in the next 15 years. So there's a lot of people that are coming to be employed here in Cyprus. We established in 2,000 square meters of offices and research laboratories that the Cyprus University of Technology is giving to us. We have, and we're going to invest in the next 7 years in state-of-the-art remote sensing and research infrastructure. As I mentioned before, we are buying a lot of equipment to support our research. And of course, we want to do a lot of uptake in innovation, in technical excellence, in entrepreneurship, establish an entrepreneurship mentality in the center. And not only that, but reach and do an achievement in world-class research, establish a digital innovation hub, establish living labs ecosystem, and engage in networking and regional exportation platforms. So we are really ambitious, as the chief scientist said, and we have a lot of work in front of us for the next 7 years. This is some of the infrastructure that we're trying to establish. You see here, DLR is going to help us to establish a receiving antenna, and Dropos, we're establishing here state-of-the-art remote sensing stations. So there's a lot of equipment that is supporting this initiative. Here we're located in Limassol, actually, in Cyprus, and we have the infrastructure in order to establish and accommodate the personnel that we are hiring in order to reach that center of excellence. Here you can see some of the equipment that we're purchasing, and we are currently into a tendering process in order to acquire the equipment. Now, in the research, we have 5 excellence areas. We establishing that through the Digital Innovation Hub, we're going to reach and establish excellence in access to energy, disaster and risk reduction, water resource management, climate change monitoring, and big Earth observation data analytics. So we already have a business plan, and we are following that business plan. And not only that, but we are revising the business plan in order to accommodate more areas and see how we can establish these excellence areas through the Center of Excellence. Now, how we are setting up the center is actually a 2-axis model. We have 4 different areas: the infrastructure, the research area, the educational area, the entrepreneurship area. But we have, and through these areas, we have 3 different departments or clusters: is the environment and climate department, the resilient society, and big Earth data analytics, with 13 different thematic areas, which is the atmosphere, agriculture, water, land, disasters, cultural heritage, marine safety and security, energy, information extraction, visual exploration, crowdsourcing, and geoinformatics. So we are this 2-axis model is enabling us to not only work on research, but also work in education, and not only that, but providing services through establishing a entrepreneurship and networking through the industry. So the impact, what we're trying to do is provide relevant information for decision making to science, industry, to governments that they're reaching to us, in order to support policies, business development, improve the quality of life of all citizens, and generate economic growth. So this is the impact that we want to achieve. Right now, we already established the Eratosthenes Center of Excellence, and we're trying slowly to make it operational. This Eratosthenes Center of Excellence guarantees we guarantee that has an autonomous operation. It has a board of directors that is on the head actually of the governance of the Excelsior, and is established as a company limited by guarantee without share capital, with non-profit limited company. So we not only establish the autonomous head of this unit, but we establishing that we are not making profit. Everything is reinvest back to the center and back to the community and Cyprus. Just to go on, this is the board of directors. We have two formal ministers that they used to be in charge of space, Mr. Marios Dimitriadis and Mrs. Vasiliki Anastasiadou. And the president right now is one of the distinguished associate professor here in the Cyprus University of Technology, Evangelos Agilas. We have Barbara Ryan, which is the former Secretariat Director of GEO, which everybody knows that deals with space on the group of Earth observations. Rosana Zaponara from CNR in Italy. Nektarios Chrysoulakis, which is the Director of Research Foundation for Research Technology in the Fourth in Greece.
Kyriakos, sorry for interrupting you. Please try to conclude.
Okay, thank you very much. And Mr. Christos Stylianidis from the former European, which is a former European Commissioner. This is the structure. I'm not gonna repeat it. I already mentioned it before, what we're gonna have in there. And as I said before, we are here located in Cyprus. We're located in Limassol, in the south part of Cyprus. But, and we would like the next few years for everybody to visit us. It's a nice place. It's a coastal city, a lot of opportunities, and we would like to expand the research opportunities here in Limassol and in Cyprus. We are following a quadro duplex helix innovation model of industry, government, social organizations, and citizens, academia, I already mentioned before, and this is what we are basing the Center of Excellence. We have locally about more than 95 organizations, research centers, universities, and 19 Cyprus governmental departments that are supporting us. And of course, we have the national support and commitment from the government, from different ministries, and we would like to thank everybody for supporting this initiative. And we would like also to explore and help these departments to grow up and give them the knowledge and capabilities in Earth observation. CETA is one of the partners that we have, that we're setting up we are hosting the ground satellite receiving antenna, and the next few years we'll be establishing that antenna here in Cyprus. And not only that, but we are looking forward to work with them. All this, I would like to thank all the international support that we got. There are a lot of people that are watching us right now. Thank you very much for your support. And also, we would like to say that, yes, we are joining forces. We would like to, and we are looking forward to come to us, or we come and find you in order to join the forces, help us grow, and not only that, work together for projects, work together for innovation, and not only that, help the industry to grow up here in Cyprus. I would like to thank everybody, and would like to give back the continuation to the next presenter. Thank you very much.
Thank you, Kyriakos. The next speaker is Professor Andreas Anagiotos from CUTs and the Ramseni Center of Excellence, member of the National Council for Research and Innovation. The title of his talk is What the Cyprus National Council for Research and Innovation Expects from Excelsior Sustainability of the New Center.
Okay. Thank you, Diophantos.
Just make full screen, Andreas.
Okay.
It's in the slideshow tab.
Slideshow. Okay.
Is it now?
Yes, 5 minutes, Andreas. Thank you very much.
Thank you, Diofantos. The Cyprus Research Innovation Strategy framework can be found on this link right here. And this Research Innovation Strategy has been prepared by the Research Innovation Foundation and the National Council for Research and Innovation that Dr. Mastroiannopoulos leads. So this was done in 2019 and essentially focuses on the technological, social, and economic development of Cyprus based on research and innovative entrepreneurship, and has a very ambitious target to reach a national research and development investment of 1.5% of the gross domestic product by 2023 and get about half its money from the private sector. Of course, this is very challenging because, as you see in this schematic, the top schematic, Cyprus right now is only at about 0.56% of the GDP and one of the last European countries. And you realize that to reach the 1.5% GDP, we need to have an expenditure of about 400 million by 2023. In addition, we have to move forward Cyprus from being a moderate innovator, as you see on the lower schematic, to go into the strong innovators. You know, the 7 pillars that the National Research and Innovation Strategy focuses on is research excellence, knowledge transfer and commercial exploitation, innovative entrepreneurship, cultural change, international dimension, communication, and digital transformation. And you realize that for Cyprus, the bigger challenge is the knowledge transfer, commercial exploitation, the innovative entrepreneurship, cultural change, and digital transformation, that Cyprus is not used to these ideas. Of course, as Dr. Themistokleou mentioned in the previous presentation, the teaming projects are a very important component of this policy. There will be a significant factor in the formation of the research and innovation landscape between 2019 to 2023 based on this strategy. And of course, with the many applications that Eratosthenis focuses on, Excelsior is expected to support these measures, especially in the research excellence, knowledge transfer and commercial exploitation, innovative entrepreneurship, international dimension, but most importantly on the R&D investment. So the government expects that Excelsior would chip in and help reach that 1.5% of GDP by 2023. But of course, this is in line with the aims of Excelsior to reach financial self-sustainability in 7 years by the diversification in 3 pillars: the funded research and development programs worldwide, income from services to the public and private sector worldwide, and of course, we have hired a team of attorneys to draft these negotiating contracts, and income from spin-offs and IPR development. Excelsior is in a great shape to be a great contributor to this R&I strategy because it has a unique infrastructure, unique know-how and expertise with the international team that has gathered together, and the excellent potential for innovation. So what is expected from all the teaming projects by the government of Cyprus and especially Excelsior is to chip in these different pillars. In the research excellence, we're expected to hire high-quality researchers, collaborate with other academic and research institutions, produce high-impact factor publications on the knowledge transfer and commercial exploitation, to utilize these facilities and collaborate with the private as well as the public sector, to exploit our research results, to collaborate with enterprises and the industry, mobility of researchers, and provide high-quality services to industry and the private sector. Specifically on the innovative entrepreneurship, we're expected to have a good contribution on entrepreneurial innovation, develop IPR and the creation of spin-off companies, and of course, help in the international dimension and the digital transformation of the country. Now, as Kyriakos has mentioned in the previous presentation, we have a very precise business plan and where all the income is going to come for Excelsior. So we expect that about 20% would be industry and exploitation services, 30% European Union project, about 20% from the Eastern Mediterranean, Middle East and North Africa projects, about 15% from national projects, and about 15% from ESA, GEO, and Copernicus. Based on this business plan, we anticipate that we are going to have a clear implementation strategy, how this center of excellence will be self-sustainable in 7 years. with the detailed itemization of all the sections that I have mentioned in the previous slide, with a specific grant, service contract, and other sources of income. Network, we are going to have a networking team to promote the center and search for our customers, and get the members of the executive board to help identify possible stakeholders and customers inside, not only in Cyprus, but also the EU and especially the Mediterranean region, and have a very clear approach, strategy, and chronology of actions for signing the MOUs, obtain commitments, and sign the contract services from the ministries, government institutes, private organizations, funding agencies, and not only in Cyprus, Greece, the European Union, and the Mediterranean region. And in this way, we are sure that Excelsior, the Center of Excellence, will have a very valuable contribution in the research and innovation strategy of the Cyprus government and the European Union. This is it. Thank you very much.
Thank you, Andreas. Thank you very much. Let's move to the next speaker. Is Stelios Georgis from the Department of Electronic Communications, Deputy Ministry of Research, Innovation and Digital Policy, Cyprus Activities in Space. Stelios.
Hello. Hello, everybody. Can you hear me?
Yes.
Okay. So, good morning, everybody. My name is Stelios Georgis. I hope you are all well and safe. I represent the Department of Electronic Communication, and I will do a brief presentation right now. So, Cyprus is positioned geographically and strategically location in Eastern Mediterranean at the crossroads of Europe, Asia, and Africa. So what we need in order for Cyprus to be a regional electronic communication hub, first we need a vision. And our vision is Cyprus to become a society of information based on a modern technology, skills, and infrastructure. Space technologies, together with information communication technologies, can be a driver for growth, social prosperity, and regional cooperation. Space technologies are of strategic importance for economic growth, social prosperity and cohesion, protection of the environment, enhancing public security and civil defense, and for the promotion of excellence in science, research, and innovation. Cyprus needs to exploit its own capabilities. The Cypriot government has put in place a number of promising policies aimed at enhancing the adoption of digital and space technologies. In addition to that, I'm happy to announce that from the 1st of March, our department, the Department of Electronic Communications, belongs to a new ministry. In particular, DEC was transferred from the Ministry of Transport, Communication and Works to the newly formed Deputy Ministry.
Stelios, sorry for interrupting you. Just move the slides.
Yes, it's on the same slide that.
Okay.
To the newly formed Deputy Ministry of Innovation and Digital Policy. This transfer will be beneficial since the newly formed ministry has the responsibility for research policy in Cyprus. Therefore, it's a great opportunity to explore the capabilities that this cutting-edge innovation space technology offered by ECoE, especially when working very close to talented research scientists. So currently, we're working on the preparation of the national space strategy. In this context, the feasibility study of Cyprus' capability in space sector is ongoing, and the final results are expected in January 2021. The results will be very useful instrument for the formulation of our space strategy. As a country, we have several priorities regarding space technologies, which are the satellite communications, Earth observation, satellite navigation, and the enhancement of our relations with international organizations. Regarding satellite communications, Cyprus has seen major developments in satellite comms, infrastructures, and space assets. So far, important gateway facilities and monitoring stations are deployed in Cyprus for major European satellite operators, and 8 licenses have been granted to organizations, including Hellasat, to launch telecommunications satellites in orbit using Cypriot assets. Our geographical location is ideal since it is possible to have a link with the satellites flying over Asia, Africa, and Europe, which significantly supports Cyprus' goal to become a regional hub in the field of electronic communications. Regarding Earth observation, Cyprus has one of the best climate conditions. Together with the strategic location, the national infrastructure, the expertise, we can develop innovative space services and attract investment. However, it is very important the expertise gained from the academia and the research centers to be transferred to the industry, purposing the development of commercial applications which will meet user needs. Our participation in Excelsior project is part of our action plan to exploit the opportunities and challenges in the field of Earth observation. Next, regarding the satellite navigation, a relevant infrastructure which is part of the search and rescue service of Galileo systems was deployed in Cyprus. This infrastructure is a receiving earth stations capable for detecting the location of emergency beacons called MEOLUT. Cyprus is one of the 3 hosting countries of such infrastructure, thus enhancing its strategic role in the area. Regarding the collaboration with international organizations, as you all may be aware, in 2016, Cyprus signed the European Corporate State Agreement with the European Space Agency. The overall objective of the agreement, with duration of 5 years, is to associate Cyprus with ESA programs and activities and to prepare Cyprus for possible future accession to ESA as a full member. Especially, we expect to promote innovation and research in general and to create the critical mass needed for our universities and industries to be more competitive in securing more funds in space applications. Currently, we are undergoing the 4th ESA PEX call. The call opened on the 2nd of July and will close on the 31st of August. The ongoing cooperation with ESA and the big number of already secure funded projects clearly shows that despite the small size of Cyprus, there is a great potential regarding space technologies and applications. The ESA PEX program ends in July 2022. The next step of our cooperation with ESA is to be considered based on the feasibility study of space sector in Cyprus, which is ongoing, and on an assessment by ESA. Therefore, we expect by the end of ESA PEX program in 2022 to be reviewed by ESA and receive its recommendations in order for us to evaluate if we will repeat the ESA PEX program for another 5 years, or if we are going to the next step of cooperation with ESA to be an associate member. Cyprus' intentions is to strengthen our relations with ESA as much as we can. Finally, further to ESA membership, I would like to announce that in 2018, Cyprus became a member of the United Nations Committee of Peaceful Use on Peaceful Uses on Outer Space, known as COPUS. Now, with our participation in Excelsior project, the Ministry looks forward in achieving the following strategic goals, which are promoting in Cyprus the space technologies and competitive services, strengthening Cyprus' capacity in exploiting the Earth observation sector, focusing on user needs, and finally creating the critical mass of scientists and companies that eventually will beat Cyprus industry space cluster. So what is the future? The space sector is undergoing a rapid transformation due to an increasing demand for space-based services alongside the emergence of new space. The sustainable economic growth requires societies to create conditions which enables people to access quality jobs, notably in the line with the UN Sustainable Development Goals, especially in global competitive industry such as space. Cyprus acknowledged these opportunities and the opportunities that this digital revolution will offer, and we invest in space. In order to create these space-related business opportunities, the government of Cyprus, in cooperation with the private sector, must step up their efforts to stimulate skills and entrepreneurship to prevent a brain drain of highly educated and skilled experts, since these individuals are the core of such a highly demanding technology field. Finally, regional cooperation and call for increased involvement of regional and local authority is of high importance for the development of a strong space industry based on space application services. Thank you very much for your attention.
Thank you, Stegios, very much. Next speaker is Kulde Schreier from DLR. Intro to the topic: what will be the advantages and challenges for a space-related infrastructure in Cyprus? Kulde?
Yes, thank you, Fantas. You see my screen?
Yes, just.
Okay, thank you. So, welcome to this exceptional and very interesting workshop. I think we will have an interesting day in front of us. Some issues have already been mentioned by my predecessor speakers, but I'd like to point some issues here for the talks we will face and hear today. And give you some thoughts on why do we use and why we are in Cyprus and what is about Cyprus and space. First of all, as already mentioned, Cyprus is as the periphery of the European Union, but it's in the center of what the project calls EMENA. It's the Eastern Mediterranean, Middle East, and North Africa. EMENA is and has been the cradle of civilization. It's the world heritage. It's about ecology. In fact, the name Cyprus comes from copper And Cyprus was always be a hub, a trade hub, an intelligence hub for many states and many continents. So Cyprus is at the gateway of 3 continents. It is always and has been trade and commerce. But however, at the gateway of 3 continents, we have also to face conflict, claims, and migration. And this is always, and currently also now, a big challenge, but also a kind of opportunity for some kind of Earth observation. Cyprus, in its unique location in the Eastern Mediterranean, comes also with environmental richness, but this richness is endangered by global environmental change. It's by natural risk. And we might later also talk about how Cyprus can play a role and how space and Earth observation possibly can play a role in how Cyprus deals with the European Green Deal. I said already, Cyprus at this location is endangered by natural hazards, specifically by seismic hazards. We'll later see, and in the presentation, see how possibly Earth observation or space technology can help to forecast, to mitigate, and to possibly prevent these kind of hazards and the effects on our citizens. Cyprus and the Eastern Mediterranean has a specific atmosphere, a specific issue on air quality and aerosols. We'll later hear from our colleagues, especially from Tropos, how these can be measured, how this is important for the wider environment, and possibly also how it has been measured, mentioned already several times by my colleagues, how the cloudlessness of Cyprus can be of advantage for Green Deal, for solar energy and others. Cyprus is in the center of trade, specifically ship trade and other maritime activities. Earth observation can help to get a maritime awareness picture, and we'll hear later from my colleagues how this can be achieved, specifically with radar technology, with radar satellites such as the Sentinel-1 satellite of the European Copernicus program. And the necessity for this kind of observation of maritime awareness, I guess, is obvious, especially around the areas in Cyprus. In order to use maritime awareness, in order to make benefit of Earth observation for many applications, it has already been mentioned, the plan within the Excelsior project is to establish a ground receiving stations for many Earth observation satellites. And this gives the footprint in yellow of this kind of receiving station, which is planned and which DLR is happy to assist the project to establish and this station and train the personnel. So this is a unique location on European ground, but with a far east looking area in this location. We also will hear later in a presentation about other possibilities of space to ground communication, such as optical communication, making benefit of the cloud-free days of Cyprus. A colleague of mine will also present this. And finally, a summary of the possibly space infrastructure in Cyprus. It has already been mentioned, satellite to ground communication is not only about Earth observation, it's also about navigation. Some facilities about the Galileo system has already been established in Cyprus. We'll see how this can also be extended for Earth observation. We'll hear about calibration and validation sites, especially for my colleagues in Tropos, how Cyprus is a good place for this kind of measurements and how in situ and ground-based measurements can help space technology based in Cyprus. We'll hear that Earth observation specifically is currently all about big data, cloud computing, and how the project can establish Earth observation data hubs, giving access to all kinds of geoinformation data, including those from satellites. And finally, it's put here a little bit in orange and possibly is a little bit exotic point, but you might be aware that several Atlantic islands, I think we get something from Azores or Scotland, are preparing also launch sites for rockets. Not far from Cyprus to the east, we have in Israel a launch site which just recently launched a rocket over the Mediterranean. So this is something maybe for future consideration. The question is this sustainable? Does this generate money? And I think Marcello, the next speaker, might give some thoughts about the sustainable business in Cyprus in Earth observation. Thank you very much.
Thank you very much, Gunther, for the excellent presentation, and thanks for your great support for and full dedication in this workshop. Let's move to the next speaker, who is the final one, Marcello Maranesi, member of the External Advisory Board of Excelsior at the Adolescent Center of Excellence, Opportunities for Earth Observation Business in the MENA region. Marcello.
Okay, thank you very much, Fantos. I hope you see my screen. And the final objective and the challenge of the ECoE and the Excelsior project is to achieve sustainability. And this is really a challenge because means to obtain enough R&D funding and most important service revenues to pay for all the costs related to the ECoE, which means, as we have seen, more than 100 staff, all the operational elements, and as well as the depreciation of considerable technological investments. And in order to achieve these results, the ECoE can leverage three basic assets. First one, as already been mentioned, satellite receiving ground station. Second one is the atmosphere sounding ground station. And third, all the know-how from the CUT and the strategic partners, DLR, NOAA, Tropos, and DEC. And which are the priority domains that the ECoE will focus in order to achieve sustainability. And as mentioned in the business plan, they are climate change monitoring, disaster risk reduction, water resource management, resilient cities, and access to energy, which are all topics of great importance for the MENA region and are well supported by those assets that I mentioned in the previous slides, that are also to be complemented by advanced capabilities in big Earth data management to be delivered by ECoE and its partners. But this means that even if the ECoE will be focused on the MENA region, a broader international view is needed to achieve sustainability and to deliver value to customers, which includes operational services to European and international players interested in the MENA region. And ECoE aims to become the preferred strategic partner in that area. Second is the supply of application services to the MENA region, both the public and industry customers. And last but not least, R&D funding from Cyprus, European and international projects. And it is very important to say that this is not, R&D activities are not a goal per se, but they are a tool to develop the capabilities needed to generate value for customers. And this means that to generating value for customers means that a new process will have to be put in place with respect to the one which CUT has been implementing so far. A process that starts with the deep analysis of the end user operational process and its problems, its procedures, and then going to extract information needs that is requested by the customer to improve its performances. Then going to service requirements definition that are an input to the R&D activities. R&D activities then needs to be given as an input for full engineering of a service that then needs to be delivered on an operational basis, on a regular basis, to generate the value into the end user operational process. But this is much easier to say than to implement, especially because various interactions are needed here, here, And here, and even more, there are continuous interactions among all the elements, the steps of this process. And from my personal experience, I repeat, this is much easier to say than to implement. And in the end, the real challenge for achieving sustainability and implementing a process like this is to implement a new culture, which can only be achieved by proper integrating new people, so new culture elements within the current existing ECoE staff. Thank you for your attention.
Thank you very much, Marcello, for the excellent presentation, and thanks for your great support during the establishment of the ECoE and your great support in the Excelsior project. Thank you very much. Let's move to the next chairman. There are no questions. Some questions have been answered directly through the portal. The next chairman is Gunther Schreier from DLR. Gunther?
Yes, thank you, Fantos. I take over, and without any kind of break, we are in time for starting at 10 o'clock with the Excelsior plans of the Excelsior partners. And the first presentation will be by my colleague Egbert Schwarz from DLR Neustrelitz about a satellite ground station for maritime security. So, Egbert. Egbert, you are muted. Unmute yourself, please.
Maritime security. The first slide shows the background about the space capabilities available, and you can see during the last years the Earth observation is growing a lot. We see a lot of new small satellite missions with lower cost of manufacture, more launches, more fleets of satellites supporting one mission, and this increases the revisit time and flexibility. We get higher coverage update and higher image quality and resolution, and this ends up with more data, new products, shorter response time, and more downlink capabilities. And what you can see here from the table, Earth observation in the first line shows that this is especially really growing, and you see the number of new satellite or operating systems within 2018 was already 710, and it's growing a lot. So what is the motivation for the ground station of Cyprus? We already heard it. It's the unique geolocation for remote sensing in the southeastern Mediterranean region. And I will show these on this use case support maritime situational awareness. It's one of the most dense shipping routes in the world, connecting Middle East, North Africa, and Europe, and resulting in more than 220,000 merchant vessels passages per year. And it's also a region where we see exploration and developments for new energy sources, and that increase the needs for maritime safety and environmental monitoring. Here you can see what this means, the unique geolocation of remote sensing within this region. This enables near real-time coverage for Central Eastern Mediterranean Sea, and also for the Black Sea and the Caspian Sea, as well as for the Red Sea and the Persian Gulf. And this example shows sun-synchronized orbits where we have up to 4 to 6 contacts per day and really good coverage to monitor this area. Going to another use case where we see non-synchronized orbits, we see that these opportunities increase a lot, because in this case we have more visit time and we are able to monitor areas more often by then using sun-synchronized orbits. And I can show you on the next slide what does it mean in total. Here you see when we compare such lower orbits with my examples was chosen from ICE-3 and this EgyptSat-1, where we saw 46 contacts in total for 1 month. That means we have almost 2 times a contact for a dedicated area, and I choose just a area side of Cyprus. You can see this here on the right-hand side of the slide. And compared to sun-synchronized orbits, that means we get really more capabilities to monitor this area. In the case, I use Sentinel-1, and what I find out that only 11 contacts per month was possible for this dedicated area in this really short example. So what does it mean for the maritime service domain? We see a lot of services needed for this area and which could be supported. First of all, the environmental monitoring, coastal monitoring. Then we have fishery control, search and rescue, law enforcement. That means illegal oil spill, illegal fishing, and others, among others. We have anti-piracy, migration was already mentioned, anti-trafficking and marine border surveillance as well. That means there are behind these services, and we saw this from the previous presentation from Marcello, we need these scientific issues to support this maritime domain with research, and there are, among others, the topics of oil spills, wind and sea state detection from satellite. We have bathymetry as an issue. We have, of course, vessel detection, which is quite well possible using different satellite sources. And we saw this from previous presentations that we have almost 78% cloud-free opportunities to use really optical satellites for these kind of services as well, and other services could be surface currents and land water lines. And what we already have seen during the previous presentations, this shows an example how such an antenna system looks like for remote sensing. It's enabled different kind of bands like X, S or Ka band. This is really depend on the user needs and the application which should be supported. And with this slide, I will end my presentation about this special issue of maritime security for the use of remote sensing within the project. Thank you very much.
Thank you, Egbert. Well in time. And we continue then with this kind of measuring and receiving data from space to measure atmosphere parameters from ground. And this is an handover to my colleagues from Tropos. There are 4 authors on this. I don't know who is going to present. Albert Ansmann, Johannes Bühl, Patrick Seifert, and Ulla Wandiger. So who is currently online on this, Albert, or who's going to present? Or Johannes?
It's Johannes, just
Johannes, yeah. We're waiting for him. So Johannes, you are online? Just double check whether Johannes is amongst the participants, should be.
Okay, now Johannes should be able to present.
Okay, so Johannes, go ahead with ground-based remote sensing supersite for atmospheric climate research, satellite calibration, and support of local services. So please, Johannes, go ahead.
So now you can hear me. Okay.
Yeah, yeah.
Great. Hello and welcome to my talk about the ground-based remote sensing supersite for atmospheric and climate research. Sorry, you can't see me. Now you can see me. Slowly but surely, we will get this running. So, the ground-based remote sensing supersite for atmospheric and climate research, satellite calibration, and support of local service. This is basically our job in Excelsior. My name is Johannes Bühl, and I'm from the Leibniz Institute for Tropospheric Research at Leipzig in Germany. And my talk is structured as follows. We give a short introduction to the topic. I give you an historic, basically, overview about what we have already done on Cyprus during the so-called CEST campaign at Limassol between 2016 and 2018. This is basically also a preview of what we are going to do in future. And then I will, points 3 to 5, will show you what will be possible with this new supersite at Limassol in future. So why are we, as a tropospheric research institute, going to Cyprus? We have different questions in mind. For example, what impact do aerosol particles have on rain formation? How does air motion influence the dust transport and air quality, for example, in a city like Limassol? And which precipitation forming process is dominating in the Eastern Mediterranean? Those are very pressing questions, especially for climate research and climate projections. And we think that Cyprus is an ideal location to answer these questions, and I will now tell you why we think this way. Cyprus was mentioned before as a crossroads, and this is also true from the perspective of dust research. As you can see, Cyprus is located in the center of the dust belt, so dust arrives from the east and from the southwest, from the Sahara. We have polluted marine aerosol and we have polluted continental aerosol, a very interesting mixture to do cloud and aerosol research. And that you can see that this is not only a theory, this is not, this is real. Here, an example of a dust storm at Limassol, which was really intense and had optical thickness of more than 6 or 7 or 8. Actually, we don't know exactly, but we think it was about 8. So why did we actually go to Limassol? What did we do there? Between 2006 and 2018, we carried our mobile measurement station to Limassol. We carried out an experiment that was called CEST, the Cyprus Cloud, Aerosol and Rain Experiment. We were on a parking lot of the university. You can see the containers here. And from close up, you can see the station on the parking lot here. This so-called lacrosse station is called the Leipzig Aerosol and Cloud Remote Observation System. Consists of different remote sensing instruments, a Raman lidar, you can see the hatch here, and a Doppler wind lidar, a cloud radar for measuring clouds and rain, a microwave radiometer, and a disdrometer, this ET-like thing on the left top corner. So, and that you can see what we can measure with this system. I give you an example of a dust inbreak that was measured with our poly Raman lidar at Limassol, with a similar poly at Phenocalia, a poly at Haifa, and during this campaign in April 2017, even a research aircraft from German DLR came to Cyprus, and we were all measuring together. So this is, for example, a good example how you can provide a real a regional overview about, for example, such a dust outbreak, also for decision makers, and just to monitor such an event, that everybody knows what's coming. And one additional example of how we try to characterize the atmosphere is, for example, shown in this plot. It is a 1-year average of the local air dynamics measured at Limassol. The arrows indicate the wind direction in a certain height. And if this is too theoretical for you, here is a depiction, 3D depiction, and you can see the wind direction and strength. So color indicates strength and the arrow direction. You can see the wind direction over time. This is in the morning. The wind is coming from the mountains in Limassol. So this is Limassol Bay. If you're not familiar with the island, this is Limassol. And you can see Akrotiri to the left and Troodos Mountains in the back. In the morning, the wind changes, so the sea breeze is setting on, and now during noon, you have a fully developed sea breeze effect. And in the evening, the air comes back from the mountains. And I think those measurements are very interesting also to assess air quality at Limassol. And based on these measurements, Limassol has a potential for very, very high air quality because the city is always well ventilated with fresh air, either from the sea or from the mountains. Yeah, but this is only a preview, as I said to you. We have now the Excelsior teaming project, and we want to copy and paste Lacrosse and run it continuously at Limassol at the Eratosthenes Center of Excellence, ECoE. For that, we have already built a new poly at Tropos. You can see the fully equipped system with some nice features to run it in a arid area, for example, automated window cleaning. But the real looker is really the Poly XT LiDAR, as I showed you before. So this is ready. The rest of the equipment is, we are in the process of buying it, but this container will look roughly like this. So, but what can you now actually do with it? What are we going to do in future with it? So one big component is, of course, what I just showed, aerosol research, cloud research, and the research of air quality and airflow. But also, we can provide a lot of measurements for satellites, for satellite validation, because of this outpost characteristic of Cyprus. Cyprus is just for Europe. It's in the very eastern, southern corner of Europe, and we can provide a lot of measurements there that cannot be provided by other means. For example, we are in the process of calibrating and validating the Aeolo satellite in the Eastern Mediterranean. For this, the satellite switches to a special measuring mode in the Eastern Mediterranean, roughly in this area. We have a Poly XT at Haifa, and here you can see the satellite measurement on the right side and the corresponding Poly measurements on the left side. And we try to derive aerosol properties from the satellite measurements and see how good this works. The next step, this is now going into the direction of precipitation research in EMENA. We can also use the satellite and the ground-based measurements together in a kind of a synergistic way in order to get an information about what precipitation, what rain-forming mechanism is actually at work in the Eastern Mediterranean. So we use measurements of CloudSat, the so-called 2C precipitation column product, and we use the same, basically the same measurements from ground with our Lacrosse station on Cyprus. So the yellow patch on the right corner is Cyprus, the rest is the Mediterranean. We have clouds. In these clouds, ice particles form. You will have rain, and we can track this from ground. So, and what we now try to do is relay the rain rate at ground with the cloud top height and the cloud corresponding cloud top temperature. And if we bring these measurements together, we have kind of a rain statistic, kind of a temperature resolved range statistics. And the surprising thing is really that the rain statistics for Leipzig and Limassol are quite similar. This you can see on the first glance. So red is Limassol, green is Leipzig. And what you can see here is basically how much rain over the year is formed at a certain temperature. And this is a very important information, for example, for climate models, that they know what parameterization for rain they have to use. So, and here, again, the different rain forming regions. We have warm rain that is formed at positive temperatures, let's say, and heterogeneous ice formation really needs aerosol to form rain, and homogeneous ice formation starts at -40 degrees. Yeah, so we have wrapped this up for Limassol and Leipzig, but we can also do this on a global scale if we now look into the cloudside measurements. Here you can see the distribution of rain all over the world. This is basically only the precipitation that is measured globally. And for 3 spots, Leipzig, Limassol and Barbados in this case, we have collected this kind of information from the ground, and we have evaluated this precipitation forming mechanism and also from space. So you can see the dashed lines are the measurements from the satellite, and the solid lines are the measurements from the ground. And for example, for Barbados, you can see that the ground and the spaceborne measurements fit very well together. For Limassol, you see a little bit more statistics, but in principle, it's the same. For Leipzig, no measurements are available from the CloudSat satellite because it's over land, and this product of rain intensity is only can only be measured over the ocean. So, and if you now look what we are interested in, for example, and this is really now, let's say some kind of high-end scientific product, if we only look at the heterogeneous ice-forming region, where aerosol is really responsible for forming the ice, we can see that globally the Mediterranean kind of stands out. We have a lot of heterogeneously formed rain, and I mean the dust and the aerosol obviously are doing their part here. So the Mediterranean stands out from all other oceans in the world and has more the characteristic of a landmass than a ocean, let's say. With this, I conclude that Cyprus is an ideal location for aerosol and cloud-related research. In the center of the Dust Belt, the Eratosthenes Center of Excellence will be equipped with a ground-based remote sensing supersite to get a kickstart into state-of-the-art atmospheric research. And this supersite will support independent research, satellite Calval activities, and will be a research lighthouse for the EMENA region. I thank you for your attention.
Thank you, Johannes. I don't know whether I will be fine or shocked that the mechanisms in Leipzig and Limassol are very same for cloud formation. So maybe this is an indication for climate change or just physics. Thank you very much. We have another presentation on the partnering, the team out of Excelsior from NOAA, the National Observatory of Athens. And it's Haris Kontoes from NOAA. He will present to us a presentation with the title Leveraging Copernicus Big Satellite Data and Space Technology for Societal Resilience, the Generation of Science and Innovation in the Context of Excelsior for the Ultimate Benefit of the Citizen. A long title. Haris, you are online and can please share your screen with us.
Harris was online, but now
He was, yeah, he was. I just saw him in the participants. Harris, can you hear us?
Hello.
Yeah, Harris. I just
Hello,
introduced you. We see your screen, and go ahead, Harris.
Okay. Thank you very much. Thank you. Good morning. Good morning, everybody. Can I have my presentation on the screen?
Yes, sure. Please.
Hello.
Yes, please share your presentation.
Harris, you need to share your screen when you have your presentation. It's down there, a green button. Now it seems to work. Thank you.
We cannot hear
Okay.
you.
Is it okay now?
Yes, now it's fine. Yes, thank you.
So please start. Go ahead.
Is it okay now? Can you hear me? So good morning, everybody. Again. Thank you very much for being with you today. I'm giving a presentation on leveraging Copernicus satellite data and space technology to address societal resilience. As a strategic partner, we are committed to exchange with our colleagues and develop science and innovation. Of course, I mean, technologies and innovation that has been developed in the area of Earth observation research and satellite remote sensing beyond of the National Observatory of Athens, and together with our colleagues in Cyprus and in the framework of the Excelsior project to develop new strategic actions and roadmaps for the ultimate benefit of the citizens. Let me here refer to some characteristics exams just to understand how crucial it is for the societies to be able to assess and properly manage actions for preparedness, prevention, monitoring, fighting, and anticipating disasters. The unprecedented increase and doubling of drought period over the last 6 years in Central America has resulted in 16 years of drought in Guatemala, Honduras, El Salvador, and Nicaragua, leaving behind millions of people without an income. Also, in years 2011, 2017, and 2019, the prolonged drought in Ethiopia, Kenya, and Somalia has left more than 15 million of people without food and security and water. The cycle IDI that hit in 2019 the areas of Zimbabwe and Mozambique has left millions of people homeless and more than 10,000 people dead from the thunderstorm. California has experienced big fire damages in 2015, 2017, 2018, and this was due to the rise of the average temperature, reaching the maximum in the last 123 years, which in turn has resulted in 87,000 hectares of forested land and more than 3,000 houses that have been fully destroyed and 86 people killed. And because of the same reason, in Australia, you know, last year, because of the dramatic increase of the temperature and the simultaneous decrease of during the summer period, forested land, more than 12 million hectares of forested land were fully damaged by the blaze. And last but not least, of course, I'm sure we have heard that in 2018, in Greece, we had the most deadly fire ever reported in our history, that 103 people were killed by fire only in one night. If we see the official figures of the United Nations, we'll see that 1/9 people are forced to migrate due to climate change and natural disasters. And 1 billion people will be forced to flee the next 30 years due to drought and desertification. Every year, disasters drive 26 million of people into poverty. And all this has to be, of course, addressed. And the big challenge information through coordinated and sustained Earth observation. This is the main challenge for us. The Earth observation is the key information can be used for an informed decision making, so as to deal and to be tackled the priorities that are set by the UN Sustainable Development Goals, by the European Union and global directives for society, the CEST framework for disaster risk reduction, as well as the power to combat the climate change. But how is possible to get this knowledge, this information? Today we have to recently process volumes of satellite data, and not only satellite data. And in order to give you an idea of what we do, please keep in mind that today, in only 1 month, we collect 110 terabytes of satellite data. But this information in the past, let's say an array of satellites just before the Sentinel missions, we were receiving this volume in the entire lifetime of the NDSAT mission. That means in 7 years. So the data that we're collecting before in 7 years, we receive today. So how is possible to deal high performance cloud computing resources, advanced data cube and advanced data array technology, and of course machine learning and artificial techniques, and I will explain you later on with specific use cases how this is possible. And all this in order to be able to high accuracy, information on the disaster. So we have to be fast, and we have to derive information from data, which lead to data-driven decision making. This is what we do in our Center of Excellence Beyond. And these types of, this is prototype research and type of solution are provided today to Copernicus European Union Space Program to support the Copernicus core services, but at the same time to provide to the global citizens information, ready-to-use information and knowledge, so as to deal with disaster risk reduction. I will show you later on, some of these cases of research and solutions that we are providing. In our center, we are a multidisciplinary team of young scientists with high-level skilled persons. And the people that are dealing with disaster reduction, actually, they are acting in 2 pillars. The one pillar is the real-time monitoring of natural disasters. Here, the area of implementation is Southeastern Europe, Mediterranean, North Africa, Middle East, and Balkans. It's a big area, and this is the area which is covered in real time by our satellite acquisition facilities. The second pillar is on risk assessment, damage assessment, and mitigation measures, and the area here that all these services are provided at the global level. We're dealing with a vast portfolio of services. The main ones shown here that are floods, landslides, earthquakes, fires, extreme weather, volcanic activity, toxic emissions, and tsunamis activities. Of course, all this action is supported by our infrastructure, big infrastructure for collecting data, either being space data, so we are operating a good number of satellite missions, polar orbit or geostationary satellite missions, at the same time deploying drone facilities, cameras, aerial vehicle, unmanned aerial vehicle, and we are linked to terrestrial networks, environmental networks, in situ sensors, and we are linked with associated volunteers, which are providing us during crisis information from ground that is assimilated to in our models. And of course, in the Copernicus, the European Commission, and the European Space Agency has been supporting us, and we have operating 8 hubs, 8 Copernicus hubs, which are receiving more than 50,000 Sentinel images on a daily basis. Sentinel 1, 2, 3, 5 pin data are used by our services, but at the same time, we're adding all this data to the entire globe for the global user. So about 80,000 images, Sentinel images, they are disseminated over the globe using high performance networking capabilities. So everything is done, and we are running all this facility with the gigabits net. So let's now
Pantas, your voice is
because these are hub. Yes.
Your voice is kind of interrupted. Maybe you switch off your video, which decreases a little bit the bandwidth.
Okay,
so your,
I'll switch the video. Yes.
Yeah,
sure.
yeah. Maybe. Thank you.
Okay, can you hear me better now?
Yes, go ahead.
Okay, thank you. So the Fire Hub, I mean, these are some examples I was telling to you about, the services which are, or solutions of services that are built up on the big satellite data. The Fire Hub one is a solution that it is providing real-time forest fire monitoring and diachronic vertical mapping on a daily basis. The Dust Hub deals with desert dust circulation, smoke and toxic gases detection and dispersion over a very big area. The Flood Hub is performing flood monitoring and analysis of flood events. GeoHub is for the monitoring of and early warning and assessment of several geophysical disasters, including earthquakes, landslides, volcanoes. Solar Hub Atlas is providing real-time solar energy estimation, nowcasting and forecasting over a huge area, North Africa, Middle East, Balkans, Europe. We're providing support to the European Forest Fire Information System, but building us on this big satellite data. And last but not least, our center is activated by the Copernicus Emergency Management Service. And on this latter, I have to show you, this slide showing that only in the last 2 years, more than 22 countries over the globe have activated us to provide information on flood risk, flood extent, forest fire risk at a large scale, seismic risk, damages at the level of the city block level, landslides as they have been caused by heavy rains or earthquakes, volcanic assessment, tsunami modeling, the tsunami, how they have hit the coastlines, coastal erosion, soil erosion, industrial accidents, and how the toxic gases are circulated, and the information which is useful for humanitarian crisis and provision of humanitarian aid. On a daily basis, big satellite data received by our antennas and the Sentinel hubs that I mentioned before provide information that is daily mapping of active fires, burnt area mapping over Europe, North Africa, Middle East, and Balkans, information which is used by the European Forest Fire Information System several times in the past. Today for us, early warning and offline risk assessment is actually a driven modeling approach. And this is the big benefit that we can get from using big satellite data and the long time series of satellite data. On one hand, we build large volumes of satellite data, large databases of data that are enabling us to map disaster events. For example, diachronic fire mapping or diachronic flood mapping. On the other hand, we collect time series of meteorological data, site-specific environmental data, information which is linked to the reported, to the mapped damages. So in the middle, there is a data-driven model, an artificial neural network model, which actually links the knowledge on meteorological conditions, on site-specific environmental conditions with the occurrence of a damage. And in the end, a neural network system, a validated model, learns the conditions under which a disaster has occurred. So this is for us today disaster risk, either being fire risk or flood risk or any early warning or alerting system, that it is building on the heritage, on the knowledge of the last years, on how a disaster has occurred, and building on this knowledge to provide short-term forecasting risk assessments. For example, I give you here, the fire risk for risk, how we provide this today into our center of the Center of Crisis Management of Fire Brigade Authority. We have mapped the fires over the last 35 years. We link them to the meteorological conditions and the environmental conditions in these areas, site-specific information, so and we have been able to understand the wildfire patterns and regimes over the country. The same is also done for floods. We have been processing ERS1, ERS2, and VSAT, and today's Sentinel-1 data over the years. We map the flood extent. We know what is normal and what exceeds the normal in a specific area, so as a system is able to provide us an early warning and an alerting message that something is going wrong in this area. But also, the real-time monitoring, crisis management, and situation awareness picture, which are real-time conditions actually during crisis, need to speed up the process using artificial neural network techniques so as to enable millions of model simulation to take place in a few minutes, so as to address dynamic awareness and to process the big satellite data. Here you see the very, rather recent early warning flooding system, which is based on the use of a neural network that is learned so as to link information which comes from satellite data or crowd information, which is providing an insight of where and how the flood exists in certain areas, so as to retrieve for a big database of flood scenarios, the one that it is best fitting to the information that it is provided to us in real time by the satellite or crowd. So the system either receives information from a satellite or information from our volunteers, from peers which are acting on the ground. And when we receive 3 up to 4 points of flood extent, it retrieves from the big database the flood scenario that best fits to the information we receive from crowd or from the satellite, and gives the flood extent over the entire river basin. This is a real-time situation awareness picture which is updated every 5 minutes and provided to the disaster control room. The same is also the Solar Hub sensor solution, which integrates Meteosat data, GOM2 data, Copernicus atmospheric monitoring, model data for aerosols, and a neural network techniques applies a radiative transfer model and performs 1.5 million simulations in less than 1 minute, so as to be able to provide in real time solar energy nowcasting and forecasting over a huge area, which is the North Africa, entire Europe, Middle East. Last but not least, I present you the Fire Hub service, which is the so-called space-based hub for fire management services. This comprises of 5 pillars: the early fire detection and real-time fire monitoring, the rapid burst current fire severity mapping during crisis, the detailed burnt area mapping and damage assessment the next day after the fire extinction, diachronic burnt area mapping, and the early forecasting of fire smoke dispersion during crisis. And all this, of course, is based again on different types of satellite data and big satellite data. And this service has received the best service, the best prizes, the best service standards in the Copernicus Master Competition of 2014. It is protected by patent. The main innovation of this service is that it provides to the control room of the Fire Brigade Authority every 5 minutes information about the fire spread, real-time fire monitoring actually, or near real-time fire monitoring, at the spatial resolution which is 50 times better than the resolution of the ingested satellite data. So we are ingesting Meteosat data, which are of 3.5 kilometers spatial resolution, but the information that automatically gets to the center of crisis management is of 500 meters. And all of this is, of course, by assimilating real fire spread modeling with satellite data and crowd data. And this is, gives you an idea of how was delivered the service in 2007 during the disastrous fire summer period in Greece. But this is at the spatial resolution of 3.5 kilometers. But if you see that slide, you will see that today the fire brigade authority is receiving on a 5-minute basis this type of information, which is 50 times better in spatial resolution. And this is an objective observation. It is not a model observation. So it gives everywhere over the Greece's territory the extent, I mean, the evolution of the fire from the first time the fire is detected by the satellite. And of course, on an hourly basis, we run the FlexPark model so as to provide information about the circulation of the smoke over the affected areas. And it is information in 2D and 3D. And this is the complete processing chain. To the top left, you see, I mean, the fire that has been detected in an area 10 minutes after the first alert, if you want. And from this point, and then the fire is followed, and it is monitored on a 5-minute basis. But continuously, our antennas are receiving satellites, I mean, like Aqua, Terra, Stormy, and PP, and they are providing on a daily basis the damage extent, which of course, I mean, is evolving day by day. And on the third or fourth day, I mean, as soon as the first Sentinel-2 image is also automatically ingested into the system, it is provided the high resolution fire damage so that it is, I mean, all this is information, real-time information, which is provided to the fire brigade authority. And of course, for the very next day, I mean, after the fire extinction, we are deploying drones and, you know, I mean, all the more traditional stuff so as to be able to map the damage at the very high spatial resolution information, which is of course delivered to the authorities, again, to the ministries for taking, I mean, taking all the appropriate measures to support the people that have been hit by the damage. The Geo-Observatory service is also a fully automatic service, which is built upon bigger Sentinel-1 synthetic aperture radar imagery. It's a fully automatic processing chain. It's a very complex processing chain, which is ingesting in real-time Sentinel-1 data. It's done all the pre-processing at cloud computing facility, generates stacks of interferograms, and uses these stacks of interferograms so as to derive ground velocities along the line of sight of the satellite. And this is a global service. I mean, it triggered any time a geohazard event like an earthquake or a volcanic activity is occurring in every place of the globe. Here you see some examples. This is the, of course, I mean, I have collected some examples from Greece, but if you go into the beyond side, you will see, I mean, many examples from all over the globe. But this is, I mean, the unrest period of the Santorini volcano that happened in the years 2011, 2012. The Santorini volcano, I mean, was again activated and had an uplift and downlift of the whole island of the order of 15 centimeters per year. It was a continuous monitoring of a fully automatic monitoring of the volcano. This is another example from the big earthquake that struck the island of Kefalonia in 2014. What you see here, I mean, you see this peninsula of the island, which is given here in blue, and this peninsula actually is showing that the earthquake, this blue color, indicates that the whole peninsula has moved to the north and up by 30 centimeters because of the earthquake. Because it's very, I mean, it's very significant information to be able to model the earthquake phenomenon. And of course,
Haris, sorry for interrupting you. Can you please try to conclude because we are running out of time? Thank you.
I just concluded. Thank you very much for your attention. Hello, are you there?
Thank you. Yeah, we are still there, Haris. Thank you for presentation, and thanks especially for Noah to be within the team, because why and how could we from Leipzig and Munich and Neustrelitz tell the Mediterranean what to do and lead in Earth observation? So Noah is a valuable asset, of course, as a Greek partner in the Excelsior team. We have still a little bit time. I just recognize also for all the participants, 114 as of now, there is a button of question and answer at the lower part of your screen. So if you want to have a question and answer, you can anytime type it in, and the moderator is going to forward this, or anybody in the team is going to respond to this. So please use the question and answer button. There is some question, and while we talk, somebody in the team is going to answer it. I guess we are done, and the next session is going to start at 11 hours, which is 10 in European time, and some is even earlier. So I guess we make a short break, but stay with us, and we resume in about 10 minutes. But again, if you have currently any remarks or any question, please go ahead and use the Q&A button.
I see a question for the Geo Observatory. Can I reply this?
Yeah, go ahead. Go ahead, Harris.
Okay, yeah. Okay. Okay, I see Andreas is asking about, not Andreas, but anyway, I see someone is asking about the Geo Observatory service that they just presented. I mean, a lot of information can be found on our website of the Beyond Center of Excellence. It's there you will see on the first page of the Geo Observatory all the different types of solutions I just presented. If you click on the Geo Observatory, you will see all, you'll get enough information and all the in the different cases and geohazards that have been observed, reported. And from this page, you can download all the interferograms before or co-event, let's say, interferograms. They are available for downloading and to be used by the users of the or the ones that would like to build up on this their own research.
Thank you, Aris. There's also a question to Egbert. How many satellite sensors the proposed satellite station in Cyprus can accommodate? Egbert, you are still online and with us and can possibly respond to this. How many satellites, Earth observation satellites, the proposed station can accommodate? Egbert?
Yeah, it's really difficult to answer because the specification of this antenna system is not finalized yet. And therefore, it's also highly dependent on this orbit and the scenario which could support it from the satellite station. What I can say is that normally each satellite overpass would be within 10 to 15 minutes. And there's a kind of preparation phase for the antenna system to support the dedicated satellite mission by the configuration which is needed then for these dedicated satellite. And therefore, yeah, this highly depend on such mission requirements. I would say one antenna system may be 10 to 20 missions or overpasses per day is not an issue.
Yeah, and from the technical point of view, depends on which frequency bands we go, but the normal, let's say, Earth observation satellites, the Landsat, the Sentinels, and also the commercial satellites could be accommodated if needed with this kind of station. But the process, as Egbert says, of requirements, finding and definition of the station is just ongoing.
Yes.
Any further questions or remarks from the speakers? There's no further Q&A there. Okay. Then in about 5 minutes, we will go ahead with the next station, next session, break. Okay. So see you in about 5 minutes. We have a very brief break. Thank you.